1%. Basic Percents, with your host, me, Catherine. First of all, we need to talk about the meaning of percent. Percent means per 100. The prefix cent or centi is from a Latin word meaning 100. There are lots of English words that have the same prefix. A centenarian is a person who lives to or beyond the age of 100 years. A century is a period of 100 years. The 20th century was a century that began on January 1st, 1901 and ended on December 31st, 2000. A centimeter is a unit of length in the metric system, equal to 1/100th of a meter. And then we have this. The percent sign is used to show the number of parts out of 100 parts. Let me show you what I'm talking about. In this square, there are a total of 100 little squares. How many shaded parts are there? Or how many shaded squares are there? There's 11. How many total parts are there in this square? 100. We could say there are 11 per 100. And guess what? That's 11%. And that's it. There are 11% shaded. And that's basically all a percent is. A part of a whole. Let's look at a couple more examples using my Fitbit. A Fitbit is a watch that not only tells me the time, but it tells me how many steps I've taken, how many calories I've burned, and so on. This is just an example to show you the basics of percent. Don't freak out if you're not sure how to use the calculator to divide or anything like that. Don't worry. Let's get right to the examples. The first example, I'm going to be looking at my steps. They're right here on the left. What percent of steps have I completed? Remember, percent is part over total. The number of steps that I've completed so far are 13,097, so that goes on the top. If you look a little bit to the right of where I have my steps, it says 18,000. That's how many I need to complete for the day. All I have to do then is divide to get my percent, 72.8%. What exactly does that mean? It means I've completed 72.8% of my steps for the day. What percent of steps do I still need? Well, remember, percent is always based on 100. If we take 100%, that's if I did all the steps today, and minus 72.8%, those are the steps that I have completed. The answer is the steps that I still need to take, 27.2%. That means I only have 27.2% of my steps left. Cool! Let's look at another example. This time, I'm going to be looking at my active minutes. What percent of my active minutes have I completed? Well, remember, percent is part over total. If we look at my active minutes, it says that I've done 17 active minutes so far. If I look at my table, to the right of 17 is 30. That's how many active minutes I need today. That goes under my total. Let's do some magic, and it turns out that I have 56.7% completed. Let's do some magic, and what do I get? 56.7%. What exactly does that mean? Well, I've been active 56.7% of my goal. All right, but what percent of active minutes do I still need to do? Once again, remember, percent is always based on 100. So we're going to take 100%. That's if I did all my active minutes, minus the active minutes that I've already completed, 56.7%. When I subtract, I get 43.3%. What does that mean? I still have 43% of my active goal left to complete. I better get walking. In this one, we want to change percent to a decimal. It's super easy, by the way. To write each percent as a decimal, move the decimal point 2 places to the left. Yeah, that's it. Sure, there are some instructors out there that'll say, oh, you need to divide, you need to do this and that. No, no, no. Just move 2 places to the left. Let me show you. Here's my decimal place. I'm going to move 2 places to the left, and I end up with 0.23. Now this is called the leading zero, but it doesn't hold a place value. When I have my students do this, I always ask them to put a 0 before the decimal place. I hate to tell you, but some of you have some really bad handwriting, and it's really hard to see where the decimal is. Sometimes my students do it, and sometimes they don't. But according to Dr. Rick from the Math Forum, it's a good idea. He says, my reason for this is very practical. The decimal point can get lost easily, and having the 0 there gives the reader an extra clue to look for the decimal point. You should also know that they do it in chemistry and biology and all of those ologies all the time, so you might as well get used to it. Just so you know, they do this in chemistry and biology and all of the sciences, so you should just get used to it. Let's look at the next one. Let's change 153% to a decimal. Here's my decimal. I moved 2 places to the left. Yeah, 1.53. Let's look at the next one. Here's my decimal. I moved 2 places to the left. Now in this case, I have to add a 0, and this one does hold a place value. What's my answer going to look like? 0.091. Cool. Let's look at 76%. Here's my decimal. I move 2 places to the left, and we end up with 0.76. Let's look at 0.18%, or 1800ths of a percent. Here's my decimal. I move 2 places to the left. That means I have to add a 0, and it's not just a placeholder. So what's my answer? 0.0018. Let's look at the last one. 400ths of a percent. Here's my decimal. I move 2 places to the left, and once again, I have to add the 0. What's my answer going to look like? 0.0004. Cool. Now that we know how to change a percent to a decimal, we're going to learn how to change a decimal to a percent. To write each decimal as a percent, move the decimal point 2 places to the right. Yeah, that's it. Now once again, I know that a lot of teachers and instructors are going to say, no, you need to do this, you need to do that. No. Trust me, you're just going to move the decimal point 2 places to the right. Let's look at our first one. 0.56. Here's my decimal. I move 2 places to the right, and I get 56%. Let's look at the next one. 0.034. Here's my decimal. I move 2 places to the right. Yeah, 3.4%. You're going to notice that I'm adding the percent sign too. What about 0.007? Well, here's my decimal place. 2 places to the right, and I get 0.7%. 0.99 as a percent, well, here's my decimal. Move 2 places to the right, and it's 99%. What about 1.88? Here's my decimal. I move 2 places to the right, and it's 188%. Do you see, this isn't so bad yet, is it? Let's look at the last one. 0.341. Do you remember how we say that as a decimal? 341 thousandths. Yup. Just checking to see if you remember. But let's make it a percent. Here's my decimal. I move 2 places to the right, and I end up with 34.1%. Now it's your turn to practice. You're going to pause the lesson, solve them, and then press play to check. All right, let's see how you did. In the first column, we're going to change percent to a decimal. Let's look at the first one. Did you get 0.89? Awesome! Let's look at the next one, 0.46%. Yep, 0.0046. Cool. But if you didn't get it, let me show you how I did it. Here's my decimal, and I moved 2 places to the left. That means I have to add a 0 in there. That's how come we have 2 zeros after the decimal. Let's look at 9%. Did you get 0.09? And the last one, 12.8%, 0.128. Good. In the next column, we're going to change decimal to a percent. Remember, we're going to be moving 2 places to the right. 0.7 is 70%. 0.22, 22%. 0.456 is 45.6%. And finally, 0.002, yeah, that's 0.2%. Now, how did I get that last one? Well, here's my decimal place. I move 2 places to the right, and that's where my decimal goes, right before the 2. Now here's the self-quiz. You're going to pause the video, solve without peeking, and then press play to check. All right, let's see how you did. For number 1, the first one, we're going to change the decimal to percent. 0.128 is, well, we moved 2 places to the right, 12.8%. 0.02% changed to a decimal, well, it's going to be 0.002. Cool. How about 0.75? What's that as a percent? Well, we're moving 2 places, 75%. What's 96% as a decimal? This time we're moving to the left and we get 0.96. I shouldn't act surprised, but it's pretty cool. Let's change 0.183 to a percent. Here's my decimal. I moved 2 places to the right, 18.3%. And finally, we're going to change 708% to a decimal. Here's my decimal, 2 places, yeah, 7.08. Great! So we've talked about how to change decimal to a percent and percent to a decimal. This time, we're going to talk about how to change a percent to a fraction. And it's actually way easy. Yeah, we just drop the percent sign, write the number as a fraction over 100, and reduce if needed. Yeah, that's it. Let's do it. I'm going to write the number. I'm dropping the percent sign. I'm writing it as a fraction over 100, and then reduce if needed. And guess what? It doesn't reduce. So 23% is 23 over 100. Let's look at the next one, 54%. I drop the percent sign, I make it a fraction over 100, and then I reduce if needed. Now these are both even numbers, so I know that these are both even numbers, so I know 2 goes into both of them. I'm going to cancel their common factor, and we end up with 27 over 50. 54% written as a fraction is 27 over 50. Let's look at our last one. Once again, I write the number without the percent sign. I make it a fraction over 100. If you don't remember, this is called an improper fraction because the top, or the numerator, is larger than the bottom, or the denominator. We could also write it as a mixed number, which contains a whole number and a proper fraction. Depending on the question, if it asks for an improper fraction, you need to put 117 over 100. If the question asks for a mixed number, you better put 1 and 17 over 100. If you don't remember how to change from an improper fraction to a mixed number, or a mixed number to an improper fraction, I have a whole video just talking about that. Just return to the fraction videos and check it out. What happens if I have a decimal percent and I need to change it to a fraction? Oh my gosh, hyper easy again. We're going to drop the percent sign, Write the number over 100. The decimal changes to a whole number by multiplying, and then we reduce if needed. It sounds like a lot, but it's actually super fun. Let me show you. 1.7, and we write it as a fraction over 100, just like we did in the last screen. Now, I need to change this number into a whole number. That means I have to move the decimal one place to the right. That means I'm going to multiply by 10. Why do I multiply by 10? Well, I multiply by 10 because we moved one decimal place. 1.7 times 10 is 17. But if I do it to the top, I have to do it to the bottom. So I'm going to multiply 100 by 10, and we get 1,000. Since 17 over 1,000 doesn't reduce, that's it. That's my answer. Let's look at 9.14%. Once again, we write the number without the percent. We make it a fraction over 100. We need to change the decimal to a whole number. That means I have to move the decimal place 2 places. So I need to multiply by 100. I'm multiplying by 100 because we moved 2 decimal places. And that gives me 914. But if I do it to the top, I have to do it to the bottom. So 100 times 100 is 10,000. Remember, we still need to reduce if needed. And since they're both even numbers, I know they're going to reduce. It just so happens that 2 goes into both of them. I cancel out my common factor, and I end up with 457 over 5,000. And that's it. All right, this is your chance to practice what we just did. You're going to pause the lesson, solve, then press play to check. All right, let's see how you did. 44% as a fraction. Remember, we drop the percent sign and rewrite it as a fraction over 100. Now we need to reduce. Well, it so happens that 4 goes into both of them. I cancel out the common factor and I end up with 11 over 25. Let's look at 151%. We write it without the percent sign, make it a fraction over 100, and we realize it doesn't reduce. If you notice our directions, it asks us to round if needed, but do not change to a mixed number. Let's change 0.4% into a fraction. First, rewrite the number without the percent sign. We change it to a fraction over 100. We don't like the decimal in the top or the numerator, so we need to move one place to the right. That's the same thing as multiplying by 10. 0.4 times 10 is 4. But remember, whatever we do to the top, we have to do to the bottom. 100 times 10 is 1,000. But then, do you notice that we have even numbers? Yep, we sure do. And it just so happens that 4 goes into both of them. I cancel out my common factor, and I end up with 1 over 250. Let's look at the last one. I write the number without the percent sign. I make it a fraction with 100 in the denominator, or the bottom. I don't like decimals in the numerator or the top, so I know I need to move the decimal 2 places. That's the same thing as multiplying by 100. 1.57 times 100 is 157. But remember, whatever I do to the top, I have to do to the bottom. 100 times 100 is 10,000. And guess what? It doesn't reduce. Okay, now we're to the dreaded fraction percent. But we're going to do the same thing. We're going to drop the percent sign, write the number as a fraction over 100. Then we need to rewrite a division problem. That means we're going to rewrite it with the division symbol. Don't worry, I'll show you what that means. Solve, and then reduce if needed. Let's look at our first one, 37%. I write the number without the percent, and then I write it as a fraction over 100. Hopefully you remember way back when we talked about multiplying and dividing fractions. This is the same thing as 3/7 divided by 100 over 1. Remember, 100 is just a whole number, and to write it as a fraction, I put 1 underneath it. But when we divide fractions, we change it to a multiplication. And you remember what we do? Yeah, we flip-flop the second fraction. Let's multiply straight across, and we end up with 3 over 700. This doesn't reduce, so that's my answer. 3/7% is 3 over 700. Let's look at the next one. I write the number without the percent sign. Then I write it over 100. Cool. The next thing I do is I change it to a division problem. The next thing I need to do is rewrite it as a division problem. So 2/5 divided by 100 over 1. Remember, 100 is a whole number, and anytime I want to write it as a fraction, I write it over 1. Now that we're dividing fractions, we have to change it to a multiplication and flip-flop the second fraction. When we multiply straight across, we get 2 over 500. Hopefully you recognize that 2 over 500, they're both even numbers. It just so happens their common factor is 2. When I cancel that, I end up with 1 over 250. 2/5% is the same as 1 over 250. Now that wasn't bad at all. What happens if we have a mixed number? It's exactly the same, except for one important piece. We need to change the mixed number into an improper fraction. Let's review how we do that. In the numerator, we're going to take 5 times 8 plus 3, and then the bottom, or the denominator, is the same, 5. 5 times 8 plus 3 is 43 over 5. It's still a percent because we haven't divided by 100 yet. All right, first thing we do is drop the percent sign. We write it over 100. We change it into a division, 43 over 5 divided by 100 over 1. But when we divide fractions, we have to change it to a multiplication and flip-flop the second fraction. When we multiply straight across, we get 43 over 500. And guess what? It doesn't reduce. So 8 3/5% as a fraction is 43 over 500. Let's try another one. 2 2/7%. The first thing that we always have to do is change the mixed number into an improper fraction. So let's do that together. In the top, or the numerator, we're going to take 7 times 2 plus 2. And the denominator, or the bottom, stays the same. 7 times 2 plus 2 turns out to be 16 over 7. Remember, it's still a percent because we haven't divided by 100 yet. Let's start our rules. The first thing we do is write the number without the percent sign. And then we write the fraction over 100. We need to change this into a division problem. So we'll have 16 over 7 divided by 100 over 1. But when we divide fractions, we have to change it to a multiplication. So what we do is we change it to a multiplication and flip-flop the second fraction. When we multiply straight across, we get 16 over 700. Do you notice something interesting? Yeah, they're both even numbers, so we have to reduce. Their common factor is 4, so when I take out the 4, I end up with 4 over 175. 2 2/7% as a fraction is 4 over 175. Now it's your turn to practice. You're going to pause the lesson, solve, then press play to check. All right, let's see how you did. We're going to work these together. 1/9% as a fraction. The first thing we do is write the fraction without the percent sign. Then we write it as a fraction over 100. Then we write it as a fraction over 100. We change this to a division problem, so 1/9 divided by 100 over 1. When we divide fractions, we have to change it to a multiplication and flip-flop the second fraction. Multiplying straight across, we get 1 over 900. Let's change 5/6% into a fraction. The first thing we do is write the number without the percent sign. Then write that number over 100. We're going to change this using the division symbol. So 5/6 divided by 100 over 1. Hopefully you remember, when we divide fractions, we change it to a multiplication and flip-flop the second fraction. When we multiply straight across, we have 5 over 600. Hopefully you notice that 5 goes into both of them. I cancel the common factor, and I end up with 1 over 120. Let's change 4 3/5% into a fraction. The first thing I have to do is make it an improper fraction. I'm going to take 5 times 4 plus 3 all over 5. 5 times 4 plus 3 is 23 over 5%. Now I'm going to write it without the percent sign over 100. We're going to rewrite it using the division symbol. But whenever we divide fractions, we have to change it to a multiplication and flip-flop the second fraction. That gives us 23 over 500. Since that doesn't reduce, that's our answer. Let's do the last one, 1 2/3%. First, we're going to change it to an improper fraction. So 3 times 1 plus 2 over 3. 3 times 1 plus 2 is 5 over 3%. Now we write that number without the percent sign, and then we write that as a fraction over 100. We're going to change it using the division symbol. But whenever we divide fractions, we change it to a multiplication and flip-flop the second fraction. We're going to multiply straight across, and we get 5 over 300. Hopefully you notice that 5 goes into both of them. I'm going to cancel out their common factor, and I end up with 1 over 60. Okay, here's your self-quiz. You're going to pause the video and solve without peeking. When you're ready, press play to check. Let's see how you did. We're going to change 7/8% into a fraction. First, we write the fraction without the percent sign. Then we make it as a fraction over 100. We're going to change that into a division problem. So 7/8 divided by 100 over 1. Anytime we divide fractions, we change it to a multiplication and flip-flop the second fraction. Next, we multiply straight across, and we get 7 over 800. Nope, 7 over 800 doesn't reduce, so that's our answer. Let's change 6 2/9% into a fraction. Well, the first thing we have to do is change the mixed number into an improper fraction. 9 times 6 plus 2 is 56, so we have 56/9%. Now we just follow our rules. We write 56 over 9 without the percent sign. Then we create a fraction with 100 in the denominator, or the bottom. So we have 56/9 divided by 100 over 1. Whenever we divide fractions, we change it to a multiplication and flip-flop the second fraction. Next, we multiply straight across. So we end up with 56 over 900. Did you notice that they're both even numbers? Yep, and it so happens that 4 goes into both of them. I'm going to cancel their common factor, and I end up with 14 over 225. Let's look at our last one, 5.6%. Once again, we write the number without the percent symbol, over 100. But I don't like a decimal in the top, so I'm going to move it one place to the right. That's the same thing as multiplying by 10. So we end up with 56 in the numerator, or the top. But remember, whatever you do to the top, we have to do to the bottom. So 100 times 10 is 1,000. It just so happens that 8 goes into both of them. I cancel out their common factor, and I end up with 7 over 125. Great! I'd like to thank you for watching, and if you really liked it, you could pin me to Pinterest. Did you know that I have video guides and worksheets available for all of my Pre-Algebra lecture series? Yeah! just go to Teachers Pay Teachers. Make sure to subscribe because you don't want to miss the new videos. I love math and I love explaining how to do it. Have a request? Let me know at picrustable@gmail.com or in this YouTube comment box below. Thanks for hanging with me, and I hope you'll join me again real soon.